Welcome to everyone. This is the fourth lesson of the course on agent-based model for simulation in the MADAS master program. In the starting part of my conversation, I have to recover two elements I forgot. One was for Gabriele. I promised to show you the path where Python can find the libraries, and then I forgot to do that. A good place to find how to use the path is within SLAP, my SLAP structure. Hi, Julia. Within my SLAP structure that you have online or you can install in your machine, there is in the folder 6 now I will enlarge a file start. I open it with a plain reader. Okay. In this start file, I am looking for the files in the directories, and I am looking if the user has a predefined project to launch. And after all these controls, here you see that importing the SYS, the system library, I can control the path. Sys path is the path of the system, and I can append, in this case, this specific folder that I am using with priority. So this is the way to modify the search of Python for the libraries. The default one is current folder, Python folder, and then if Python is not finding what is searching, it will search in all the paths of the systems. And if we add our folder there, it will be found. Okay? Not so simple, but it works. I had also forgot to run the school project, just to show how Sandro created the class with a few also nice GIFs, file.gif, containing the shapes of our class. I have to run it locally because online Turtle class, unfortunately, as I told you, does not work. But we can run the project locally. This is LAP. And I launch it in a browser, so I will enlarge the browser. You see, here I have the run file local, or the run file supposed to be used online because it contains a short memo. Locally, I don't need it, the memo. I launch the folder, I launch the shell, and as I start the run shell py program, the proposal is that of using the oligopoly folder because I'm working with Marco on this project, with Marco and Matteo, and so regularly I use it. But I can replay no, and now the system is waiting for another name of project, and if I put there school, we have the work made with Sandro. You see, this is a turtle screen. You already saw it when we were experiment with the little example. Uh, we are supposed to put here a random number seed to start the simulation with a different seed, or always with the same. If I put here always the same seed, I choose one to have a random seed, not random, but coming from the clock. And how many cycles? We start only the presentation, 3 cycles. And you see now the construction of the class with the pupils, and they start acting. They are making blah, 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 because we are in the beginning of the day, and then they we have to continue talking also when the last song is running. Now they pay attention, and the plot is reporting the quantity of attention paid by the students to the teacher. A different color are strategic because we, Sandro and Tiziana, the lady you saw on Friday with the younger future pupil, Eduardo, the small baby, they were here, and they made a lot of observation about 2 classes, if I remember correctly, 2, discovering the groups, the hidden groups of the pupils, informally coordinated among them. So if I pay attention to you, but in your group there are other 2 members of the class, they will pay attention to what I am doing with you. But all the other ones are completely disconnected immediately. They start talking, playing, and so on. It is terrifying to teach to small boys and girls. They are very nice, but completely not be controlled. And Sandro can report a lot of complicated events. Anyway, just to show you that you can also produce a nice rendering of your simulation. Why? Now this is a very important note. Why to spend a lot of time to do that? This is a lot of time, just to create a picture. The reply is to interact with non-specialist people. If you work with your colleagues, everyone knowing perfectly what is the use of the computer and the content of the simulation, is not necessary to create nice pictures. But if you want to dialogue with non-specialistic people, it is very important to do that. But also with high people in organization, high-level people. Now I refer you of an event without names, but anyway, I refer you about an important event. A former PhD student of mine, who has an important position in a central bank in Europe, so they are at large, decided to use agent-based simulation to study problems about the delays in payment among banks. It's a huge problem in the network of banks. An equation-based model is very significant, but not so flexible to cope with the problem. So the decision was to create an agent-based model. And my former student and the colleagues wrote a paper for one of the central directors. The reply was no. Terrible. They created a very nice model with a lot of pictures, moving the payment as red if in delay or blue items among the banks. And the reply was okay, let the same person. The power of images with non-specialized person, non-specialized in computer simulation. Right?
And the model was kind of the same.
Yeah, absolutely. It was only the presentation. An obscure one with the structures, complicated the diagrams and so on, and an easy to be understood one. Close to a video game. This is very important. Close to a video game. Because we are all trained to understand the video game. The serious gaming side of the agent-based simulation. Do you remember in the first conversation? I had introduced together agent-based simulation and serious gaming. This is serious gaming, sure. What the goal of that? To experiment different strategies of the teacher and to observe the effect in the class. A lot of work and now a book wrote by Sandra. What?
I'm thinking once I was speaking with a girl that was doing a PhD in biology or something like that, no? And she told me that they are forced, when they write paper in medicine, they are forced to make illustration of what they do. And it's really like illustration, like a child that want to explain to someone that doesn't know nothing, like what they're doing, like the bacteria and everything, no?
Sure.
So if you show like the image from the microscope, no one will understand what they're doing.
I agree.
And so they are forced to hide or to become illustrator
Yeah.
what they're doing.
Thanks. I close this. Unfortunately, the turtle class is very powerful, but is not running, I repeat, if you are online. If SLAP is in Binder, in the remote execution, we have no results from the turtle window. A trick is possible using a remote connection with the screen of the server. But we are not allowed to do that with a closed server like that of my Binder. If it is my server, I can link the screen and have directly here the screen of the other computer. But this is only in a private, virtual private network, not in a public one. Stop. I close this. Let's see to close in a very clean way. All output clear. So I don't save the file with the results. I eliminate the last unuseful cell. I save and I halt anything. In this way, with quit, the kernel has been stopped and I am exiting in a nice way from SLAP. Okay. A third information, Mehdi asked me for the use for the instruction about connecting Python and NetLogo, so I send it to you, but I also reported them here. So in the lesson 3, we have also this set of infos. Finished with the preliminary communications, we jump to lesson 4. Yeah. And also in the weekend, I had a lot of return about the works. Many thanks. Someone has not finished the assignment, so no star. But anyway, I wait until the end of the work, so no deadline, and for your own works. Many compliments to Gabriele. Now, today is the winner of the most beautiful homework. The prize is very large. It's a larger pizza, you know. And remember, tomorrow is very important. At the end of the lesson, we will have pizza. How many we are? 10. So?
Where do we go?
Very close here in the square named Savoia. Square Savoia. 3 minutes from here. Between the collegio and your home. So in a perfect a strategic choice. This is random, but let me, okay, stop. Contents of the work of today. Networks mainly. But before moving to the network analysis, let me pay a few minutes of attention to the largest model I am working on currently, one of the largest I made in my professional activity, the oligopolistic model made with Professor Mazzoli, Dr. Marini, and myself. It is also a way to introduce you to the different schedules of a model. I will show it to you online and in a simplified version because the last version is more and more complicated. The outline, the scheme will be instead the last one, but the schedule is a simplified one. Let me jump to my home page just to recover all the addresses. And from my home page, I move to the online version of SLAP, but not the running one, but the file system of the version. And we have to discover 3 levels of schedule. One at the level of the observer, and 2 at the level of the model. At the level of the observer, we have the sequence of the action to be done by the observer. The observer is an abstract representation of the scholar who is working with the model to discover the results and the contents. It is late. Let's try to connect again. Okay. No, it is always the static image. I continue introducing you to the idea. And here we have a simple text describing all the steps of the observer. Instead, here we will have a simple text describing all the steps of the model, but with a specialized step opening a spreadsheet like, I don't know, Microsoft Office Excel or Calc of LibreOffice and so on. So opening a spreadsheet. Why a spreadsheet? Because it is a lot flexible, the structure of the table of the spreadsheet, having rows and columns. Go back. The folder 6 contains the projects offered as a default with the distribution of the model of the swarm, of the SLAP shell. My actual oligopoly project is not there, is in a local folder of my computer, and I connect to it, as you saw, via a default link that SLAP is employing in the starting phase. Here we look at the basic oligopoly version introduced as an example of applications of SLAP. I jump in it and I search for the file observer action text. collect structural data. In each step, we take note of all the data generated by the model. It is a pandas database doing that, and we have to order to it to collect the data. Order to the model, which is a part of the tools that the observer has. So, in this case, the observer has pandas to collect the data, the model to generate the data. Third step, collect time series. Structural data are about workers and entrepreneurs. Time series are about production, planned production, consumption, prices, employment, and so on, generating time series. Visualize the plot. Useful to look immediately to the result of my model, but if I have the necessity of a quick execution, I can also eliminate this step. This is not affecting the result. I am the observer. The important idea of Chris Lanton has been that of separating hardly the observer from the model. All things reported here are not affecting the model, only the results. So not the result, the conservation and visualization of the result. Another optional step, visualize net. Why a net? The idea of the model is that of connecting entrepreneurs and workers via networks. And the network is exactly the set of the links connecting firms, entrepreneurs, and workers. And finally, not finally, pause with n in front of it, so pause will not work. Pause is to make a pause after each step to allow the observer to have a quiet look to the result. I don't want to have the pause, so with n, I create an existing step. It will not execute it. And finally, the control of the time. Do you remember that I told you that in a natural experiment the time is running per se? In an artificial one, we have to pilot it. So we have to order to the clock to make a tick, a step. This is important. If you don't put clock here, your model will not run. It will make only the first step, and then the work is finished. With the clock, the schedule restarts from here, and so on, until we will meet the max clock number, the number of a cycle, and anything will be concluded. Okay? Quite easy. Second important, I report here, we have the visualization of series and networks. And we have a clock, all our elements. Now, model actions. Very simple in this case. Reset. At the beginning of each cycle, we need to reset a lot of data because the cycle has to start clean. As an example, to account for the consumption in the cycle, I have to clear the data of the previous cycle. The results are saved via the pandas operation about collect data and save time series. And then read scripts. What kind of script? A script reported in a spreadsheet. So here we have a reset, and then a key point, read script. Sorry. Okay. This is an idea of mine. The idea of an external script written in a spreadsheet is not in Swarm, is an addendum, sorry, but in my view, it is helping a lot to construct the schedule of the model. Now, I go here again. The schedule is an XLS file, this one. It is not possible to open it online. If I open it, there is an error. But, you see, if I select it, I can download it. This is very important. With the remote use of SLAP, you can upload file here, download file, modify a file. Hi. And in this case, I download the file. The file is here. I open it. I increase always. This is Marco. This is one of our far versions of the model. Very, very simple. The model had 6 different versions. Each version has several sub-versions. It's about 4 years of work. Very heavy in the last 2 years. And to demonstrate to ourselves that we were doing good work, we published a paper. Because you are working alone. We made several seminars. And then we decided to publish a paper. Why to publish a paper? Because we have to fight with the reviewers. And this is very important. It's heavy. But it's helping you to correct the direction, to add, to
Besides, we are very tough people and we like to fight.
Yeah, sure. But it is necessary. I am talking to postgraduate students and to PhD students. It is very important. And 4 years of work, sure, doing a lot of other things. But anyway, it's been a long way to the book that in 18 days has to be concluded. We are a bit desperate, but anyway, we will succeed. The calendar is running. You see, here we have in the first column the agents, entrepreneurs, worker, and in the second column, the orders or method or functions that we activate upon the agents. If in the second column there is a number, it is a probability. And in this case, the function is moved in the third column. There is also an abstract agent, the word state. The word state is outside the agents. In this case, as an example, is doing the calculation of the price cleaning the market. This is not done by Sandro, Pietro, or Marco. It's done by economic theory. And in the new version, we will also a more realistic version of the market without a cleaning agent. But in this case, it is an abstract one. Let's make a stupid example. The agent have to decide if to use the umbrella or not. The word state will inform them if the weather is running or sunny. This is an external element. Again, this is a trick of mine, is an addendum to the original swarm construction. But in this case, it has been very, very useful. Okay. Now, looking at the model running is not so interesting. So let me quit from the online.
Can I ask a question? I'm
Always, always.
Does the worst state change the behavior of the, affect the behavior of
It is possible. It is possible because imagine to have in the world state the clock, the activity of a class. In the fourth hour of the morning, the situation of the attention is very, very low. So I can, from the world state, inform the pupils that they are tired and they want to go home. And so they will not pay no more attention, or maybe they will kill the teacher. It's also possible.
I'm curious because
Yeah,
when
yeah.
we did a
Gabriele,
No, it's why a spreadsheet and not a text?
try to create macros in text. I allow user to create macro within the spreadsheet to create more complex structure of orders. Anyway, if you look at the content of the SLAP folder, the XLS file is translated in a TXT file. So if you want to write first directly the TXT, you can. But in a lot of cases, it's very expensive and very heavy. Anyway, there is a handbook of SLAP of about 100 pages explaining also this. Many thanks for the question. And I want to add a detail. In a spreadsheet, you can use a macro making a repetition of the thing to be done in each step. In a TXT file, you have to repeat, because if you want to have different action different days, you have to repeat and write detail of all the days. So this is another motivation for using an Excel file. One of the more difficult pieces of code of SLAP is the translator from XLS to TXT, because it's a bit obscure, but anyway, it works. Giulia?
But when the model reads the spreadsheet, there's like a code associated with it. I mean, there's like entrepreneurs and the action they make. But it's directly from the spreadsheet that the model is run?
Is directly?
From the spreadsheet? I mean,
No, 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 no. The spreadsheet is only a table. Is only a table. And anyway, it is translated in a text file, which is again only a table. The model is reading step by step and executing. It's like a note. I have to do that, and then we start. But is introducing a lot of flexibility in the code, because the sequence can be modified simply acting to a file and not to a code. Thanks for the question. Now I want also to add a new external file, currently non-existing, and I have to decide that the formalism may be XLM, the extended HTML code, to put all the parameters outside the model, to have the possibility of modifying them without opening the Python code.
sorry, just a question.
Okay, questions are very important.
When we worked about on the project, the school project, you asked us to add the XLRD file to read the spreadsheet.
Yeah, yeah, yeah.
Is still
It is always here, one of the elements
okay,
of the library that we need to run SLAP.
okay.
XLRD. It has been a lot improved. This is the simple representation of the schedule of our oligopolistic model. You see, 4 years of work.
I got it in my office.
Anyway, I don't want to explain it to you, but just to introduce you to the idea of a single step or day or time step as you want. The code will repeat all these sub-steps in each cycle. It starts resetting anything, making a production plan if it is the first day. The simulation model has to start. In one of the seminars, they asked us, but how can you begin your world? How it can start? Sure, the world exists from 80 million of years. No, the civility, 80 million of years. Our model starts in the computer. We have a starting warming up phase, generating not so important data. And we cut the initial tail, and then we have stabilized the results. And in the first day, we have a make production plan, and in all the other subsequent days, we will adapt the initial production plan. We hire and fire following the production. We produce. The consumers receiving their income plan the consumptions. We have several ways to set the initial prices. I don't explain them. In the last version that has been complicating a lot of our life in the last year, we have all the agents acting and reacting separately in the market, so creating heterogeneous price in a continuum and no more a cleaner of the market price. This is the version, the previous version with the market price. And at the end of the day, the entrepreneurs, they have to plan for the price of the next day. Then, someone is becoming an entrepreneur, looking at his entrepreneur having a lot of profit, and entrepreneur in bankruptcy go back to unemployed workers in this case. And finally, we account for two external effects. If in full employment, unions will obtain a raise in prices. And also, this is the strategic key created by Professor Mazzoli in the theoretical part of the model. Also, all the entrepreneurs are raising the wages to create artificial barriers against a new entrant oligopolist. And this is creating an effect of entry and exit of the firms within the market, generating the economic cycle. And in our view, this is an important step in the direction of a more realistic market. Marco?
Yeah, I wanted to say the question of the wages. The point is that the entrepreneurs would have interest in principle to keep wages low,
Sure.
but not so low to trigger entry, because we're assuming that if the wages are getting too low, then the weighted average of the expected profit, considering also the probability of bankruptcy, might push some workers to try to become entrepreneur instead of. It's a kind of an incentive compatible condition. Yeah, and this version of the model doesn't have the low of one price. We have a different kind of prices.
Exactly.
While a previous version, the one we published before, had still the low of one price.
With correction, anyway.
With
Individual corrections.
With individual corrections, which were under like shocks or something like that. And this is kind of more consistent with the agent-based methodology, because if we are putting the emphasis I use the word distribution in that case only to
Yeah, sure, yeah.
we have a statistical distribution of prices, which is not, of course, the statistical distribution of behavior in the modeling, but this is kind of more consistent with the methodology employed by Professor Terna, on which I cannot say very much because I'm not very expert, of course.
No. Anyway, many thanks, Marco, and you are all supposed to buy our book. This is scientific advertising. We stop it. Gabriel. Gabriele.
Like, I'm new to this ABM and everything. Now, and what I got in the beginning, like in the first lecture last month, this was that one of the selling point it was that the simplicity in how agents are modeled and can be described. It's also the assumption in the beginning. While
No,
when
simplicity never.
simplicity in the sense
No.
the parsimony
I am
of the
against
assumption.
simplistic explanations.
Okay.
Never.
Now, in fact, probably I got it wrong then because when I see this, I see something where there are a lot of assumptions, a lot of
No, nope, not assumptions. Descriptions is very different. Not assumption. It is sure that an entrepreneur has to hire if he want to increase, if she wanted to increase production, and to fire to reduce. It's not an assumption. It's a description.
I'm not sure if I've correctly understood. Probably.
Please speak aloud because we have a microphone
Oh,
working
sorry.
here.
I'm not sure that I've correctly understood what you meant, but probably did you intend to say that in conventional modeling, parsimonious modeling is a kind of positive thing because then you need less assumption and less equations to explain a large number of events. So when the model is parsimonious, it's a good thing because you're in the conventional approach, in equation-based simulation, because then you have sort of constructed a theory.
See, let's imagine how many equation a DSG model has.
Yeah,
So it's
no,
not parsimonious.
I think it is important what Gabriele said because we are interacting with the
No,
public.
if I have understood correctly, Gabriele is against assumptions.
No,
Yeah.
What I'm saying is that maybe I'm wrong, but what I got is what the good thing about the agent-based model is that you describe some agent with not so many assumptions.
I never told that. I never told that. And anyway, these are not assumptions. These are descriptions. If you don't agree with the description, change it. But you need a description. And the main goal of a simulation model of any kind, especially of agent-based one, is to create a reasoning machine. What if? Very complicated reasoning machine, but is only that. And when someone asks me, do you have verified your model with real data? My reply is that I am disgusted of the question. This is not important. Do you accept the reasoning sequence? Yeah, we can discuss of that. It is not important. If I have detailed data about the problem, I will not create the model. I will use the data.
May I add another question about connecting to what Gabriele was saying? Because I think we should take into account this kind of point, this kind of objection, because we are interacting with the public of economists who are used to the conventional modeling feature. So Gabriele is saying, in economic theory as well as in econometrics, when you have a parsimonious model, is a virtue because with a relatively small number of equation, rules, assumptions, whatever, there's a large number of implications or predictions that you can use. So probably Gabriele, by seeing the graphic, said, "Oh my God, this is really big and complicated." So no, it's not. Was not
Yeah.
So the point was, haven't we lost one of the nice things, the simplicity
If you look at my mails, in the signature, there is I am against simplistic.
No, that's right. And since I always make these comments, also I always make equations which not always are consistent with the kind of model philosophy of Hegel. I do get the punishment of drinking not wine but Gatorade instead.
I will do that.
But I think that Gabriele's objection should be taken into account in the way that we should motivate and explain our philosophy, because what we will meet in seminars and presentation is public of economists who are used to that conventional.
I repeat, if you look to a GSD model, it is not simple. Hundreds and hundreds of equations.
But the ESG model is bloody complicated. But
Absolutely.
Three equations.
Yeah, but to run it, you need a lot of details. Okay, many thanks, Gabriele. Many thanks, Marco. Now we move to the second part of the content of our course, is that of using agents in networks, both in NetLogo and in Python. We can start from NetLogo. And in NetLogo, we have a NW extension. We have also a network extension. Don't use it because it's the old one kept in NetLogo distribution for compatibility reason with old works. But the new one, NW, is a lot better. Let's have a first look to two simple cases in NetLogo. All the material is, as always, in the Dropbox web folder and online in the usual folder. But it is not important to run it now, but to have a look to my screen, because they are very, very simple codes. The one as always, I have to enlarge. Let's have a look to the code. Besides turtle and patches, patches are the square of the word, we have links. Links are items of NetLogo with attributes. To set up, reset X, clear all, create 3 agents, 3 turtles. Then I have a second button, create links, and in the first version, the other 3 rows are commented, so not working, gray. We ask turtles create link to one of other turtles. Very simple. And you see the effect. Set up, create links to one of others. So not necessarily all the turtles will be connected.
So the default option is to create directed link, like I see errors in the graph.
Sorry, I understood nothing.
This is a directed network. So
Please, please, one thing at the right time. Okay? Don't try to understand the final step when we start using the pencil. Okay? this is the creation of a link between me and you. Stop. Okay?
May I ask a silly question? Is that the way, in our model, you model the connection between the firm and the workers who are being hired by the firm?
Yeah.
So that's the way you
Yeah.
okay.
Yeah. Just in Python, in our case, just to have, in this case, a direct knowledge of the connections, having the firm knowing all the workers, but also the workers knowing the firms. And but now again, we are now in a very first preliminary step. Don't ask complicated question about nothing.
I have a silly question, not a silly question. And in the latest version, are you using simultaneously Python and that logo?
No,
No.
no, Python,
Okay. No that logo in that. Only Python in that.
Python.
Okay.
And the networks in Python are more powerful than in Tlogo. But
no need to use the
stay close to what are we doing now. Okay? All right. Now let me verify in the screen that our random construction is generated here, a unique link. I hope you can see the direction of the arrow. No? Let's increase. In this way you can see that all the links can be opened with a probe. I use the right click on the link and I can increase the size of the link. No, the size does not exist here. I have to add size. Now it exists. No, this is show size. No, it cannot exist. I cannot use it. I have to.
It's a badge. It's a badge, not a link.
Oh, thanks. Many thanks. Many thanks. I have to be exactly on. Okay. Inspect link. Many thanks. The size exists indeed. Thickness 1. You see? The arrow, because this turtle has created a link to this one. Let's go back 0. Instead here, trust me, we have 2 arrows, one here and one here. What that means? That this our turtle has created a link with this one, and this one has created a link with this one. So 2 links. We have 3 possibilities in that logo: link to, link from, link with. As I create a link with Marco, if Marco is creating another link with me, no addition. We will have a unique link because with has 2 directions. Okay. Unfortunately, in NetLogo is impossible to create a link with itself, herself, himself, and what you want. For technical reason. A link, auto link is important. As an example, in a supply chain, one of the steps can be executed by myself. So I send the middle production to myself to continue it. So in a lot of networks we have auto links. Here is impossible. You raise an error if you do that. And this is the reason to have here other to avoid error. Second case, a comment on the first row, and I activate the second one. Ask turtles create links to other turtles. You see, links, not link. And so, in this case, each turtle will be connected to the other two turtles. All will be double arrow situations. Trust me. Okay? Let me continue. I comment this. I uncomment this. Turtles are creating links, plural, with, not to. In this case, oh, bad plot, okay? In this case, no arrows. They are straight lines without arrows. We are on the same level, not me to Marco, Marco to me, okay? And the link is unique. Different possibilities, a lot more than the construction of the mathematical networks, a lot more. And the problem is that we are generating so complicated structure that is a lot of time impossible to understand them. Second example, just an error. If I am distracted and I forget the other, NetLogo is trying to connect the turtle with itself. And unfortunately, this is not possible. A turtle cannot link to itself. Error. Go away. Okay. And I close. And I don't save. Second example, always very, very simple. In the creation phase, the setup, we are spreading around 10 turtles, and then we ask them to create a link, singular, to one of the other turtles. And then we move the turtles. The effect is that the links are adapting. Sure. Okay. Now, an important observation. This world is closed. It is a good idea to have the control of the geometry of the network. Because let's see what is happening if I wrap the world horizontally and vertically. Now I create the world, and this turtle is connected to this one on the other side of the world, because this link is exiting here and entering here. So the geometry is not easy to be read. It works, sure, but it is a lot simpler if you plot your network in a closed box. Okay? The default for NetLogo is the torus, so the world wrapped horizontally and vertically, but you can switch off that. Okay? End of the first hour. Let me save the file.